Okay, so we want to fill in the missing value here so that this table represents a probability distribution. So what's happening here is we have these values, 2, 3, 4, 5. These are all of the potential outcomes in my sample space and the probability associated with each of these outcomes. These are the only possible outcomes, 2, 3, 4, or 5, and the probabilities associated. So for a probability distribution, to be a probability distribution, these two things must be true. Each probability must be between 0 and 1 inclusive, including 0, including 1. In other words, you cannot have a negative probability. You cannot have a probability greater than 1. That's impossible, right? That's the first rule. Second is the sum of the probabilities of all possible outcomes, the sum of the probabilities in the sample space, must equal 1. If these two are true, you've got a good probability distribution, right? Every probability has to be between 0 and 1, including 0, including 1. And the sum of all these probabilities must equal 1. So we know none of our probabilities are negative. None of them are greater than 1, so that's okay. Let's add 0.24, 0.5, and 0.002. We get 0.76. Right? So we get 0.76. And in order for this probability distribution to be valid, when I add this last probability, I should get 1. And the probability I need to add to 0.76 to get 1 is 0.24. And that's my answer. That's what the missing value has to be. So this table is a probability distribution. This plus this plus this plus this equals 1. And that value is between 0 and 1. So we're good to go.